Hi, this is an example problem from chapter 20 about how to do Kirchhoff's loop rule. Pause for a moment and read the question. All right, so Kirchhoff's loop rule, let's just quickly review this. It has to do with tracing through a loop of a circuit. A loop means you start at one's position and you trace through a wire, you come to the same spot. And the loop rule is based on the conservation of energy. It says when you add up the voltage changes across each element in the circuit, the sum of those is going to be 0. And that makes sense because the voltage is a energy per unit charge. It's an energy thing, and so it's conserved in this case. This figure kind of allows us to see how it works. We'll take this loop and we'll unwrap it so it goes straight through. Call the position A at the negative side of the battery 0. As you go from low to high across the battery, you get a gain. As you go through this resistor, you get a decrease voltage. You go on the wire, no change, no change. Wires have no change. The resistance is negligible. As you go through the resistor, is it up or down? Well, we're going in the direction of the current that goes from high to low. So that is going to be a drop, and hey, we're back down to 0 where we started at the negative terminal of the battery. So notice that it's really important to label the minus and pluses on your batteries, which are typically already done, and your resistors, which you actually need to do. Notice that the direction of the current is always going to dictate plus. It flows from high to minus across a resistor. This symbol here, EMF, that just means a voltage. It's an ideal voltage where a battery has no internal resistance, but it's just a voltage. Use it as you would V in general. All right, so for this one, the first step for applying the loop rule is I need to decide what are the plus and minuses on the resistors. The batteries are already done. They're always done, the batteries. But the resistor, it depends on which direction the current flows. Now, ahead of time, we may not be able to predict which direction the current flows. That doesn't matter. We can just make a pick of the current direction and then just stick with it. If we chose the wrong direction, the current values we calculate will come out negative, and we know that we picked the wrong direction. So I'm going to pick the wrong direction here just to show you. If you think about it, these two batteries, which one's going to be stronger? It's the 24 volt, so we would expect the current to go this way, and it does, but I'm going to pick the other direction just to show you how it works. So let's assume that the current in this loop goes in this direction, counterclockwise. By doing that, now I can go ahead and tell you what are the plus and minuses for the resistor, right? That's your current. It's going counterclockwise. Let's look at the top resistor. It flows from high to low. Let's look at the bottom resistor. It flows from high to low. We got plus minuses on everything. We are ready to go ahead and do Kirchhoff's loop rule for this loop. Now the loop rule is kind of like an imaginary thing. We're going to go start at one corner or at one point in the loop, and we're going to go mentally walk through the loop. We can go either direction we want, clockwise or counterclockwise, and we're going to add up. Every time we jump across a voltage change, we're going to go ahead and add that up, and then once we're back to the starting point, we set it equal to 0. So let me go ahead, and I'm just going to decide to start at point A. And I'm going to go ahead and traverse this thing. Let's go clockwise. So we're going to use Ohm's law to calculate the voltage across a resistor. And we are going to have to put plus or minuses ourselves. And for the batteries, we can just use the voltage that's given. So starting at point A, this is kind of my mental traversal here. I'm going to go here, move along. Oh, I just jumped right here. I've got a VR. What's it equal to? Did I go down or up? I went up, so this is an increase. How much? I times R. And in this case, we've got I times 12 ohms. So my first thing I'm going to write down is I plus I times 12 ohms. And I guess I'll just kind of put this below here, so just so you can kind of see what we're doing. This was VR. All right, next, keep on going. We are still circulating mentally. Nothing, nothing. Okay, we're going to go ahead and jump over, just like we jumped over this. We've got a battery. We're going down. It's a decrease, positive to negative. Let's call this one VB. And it's going to be down how much? Minus 6 volts, right? So there's your plus VB. We got to go to the next one. So keep on going along. No changes on the connecting wires. Okay, we're going to jump across this guy. We've got to use Ohm's law again. Did we go up or down? We increase from low to high. That's positive. Let's call this VR again. And this is going to be equal to a plus IR. R is 8 ohms. Go ahead and write that down for our VR in this case. Of course, I is the unknown quantity we're trying to solve for here. We keep on going, no change in voltage, no change in voltage. Okay, we're going to jump across this guy. Call this a VB for battery. Did we go up or down? We increased. How much? 24 volts. So there we go. And finally, hey, we're back to point A now where we started. We just traversed the loop. Sum is equal to 0. At this point, we can go ahead and solve for the only unknown quantity in the equation, which is I. So let's do a little bit of algebra here. I can combine, I've got 12 ohms times I here, and I've got 8 ohm times I there. 8 plus 12, that's 20 ohms times I. For these terms, I got minus 6 volts plus a 24 volt. That gives me a 18 volt. Sums to 0. And just a little bit more algebra here. Let's solve for I. That's 20 ohms times I equals minus 18 volts. Let's divide to calculate the current through that loop. We get an answer here. I is equal to minus 0.9 amps. Now, the negative sign here, that simply means we chose the wrong direction for the current. So in reality, what we should do is say, oops, that was wrong. It should go in that direction. In other words, it's going clockwise, the current. And if we want to go ahead and write our answer here, we can just go ahead and write down the positive value. We always make the currents positive here. The negative sign just told us we picked the wrong direction. That's all. That's how you do Kirchhoff's loop rule.